Hello friends, in this video we are going to study about the analogous systems. Analogous systems means that we are having two different physical systems and we are representing these two different physical systems with the same mathematical model. So if they are having the same mathematical model, then they will be called as analogous systems. So in analogous systems, we represent a non-electrical system in the way or describe a non-electrical system in a way to represent it in the form of an electrical system, and those two systems they will be called as analogous systems. So in analogous systems, a non-electrical system is represented by its electrical counterpart. So, here in analogous systems, we will represent a non-electrical system. Non-electrical system will be a mechanical system. As we know that the mechanical systems, they are of two types, translational and rotational. So we will represent the mechanical systems in terms of an electrical system. Okay, so let us consider a mechanical system and how we can represent or how we can describe or express it in terms of its electrical counterpart. So first we will study about the mechanical translational system. Let's draw the diagram of the mechanical translational system. This is a mechanical translational system having the three elements: damper, spring and a mass, and on this system an external force F is applied, and this force produces an acceleration due to which this displacement x is caused. So x is the displacement, F is the force, m is mass, so we have defined all the variables. Now if we write the mathematical model of this mechanical system, it will be F equals to m d2x by dt square plus b dx by dt plus kx. M is the mass, b is the damping constant and k is the spring constant, F is the force. Because this external force, it will be equal to the algebraic sum of the resisting forces. So this is the mathematical model of a or mathematical representation of a mechanical translational system. Now if we express this mechanical translation system in terms of an electrical system, then how we can do it? Let us consider a electrical system having the series combination of resistor, inductor and capacitor. So if we write the mathematical equation for this system, we will have so this is the equation for the voltage, and also it is the relationship between the voltage and the current. Now if we replace this current with the charge, it will be L B2Q by dt plus R dq by dt plus 1 upon C Q. So this is the mathematical representation of this electrical system. So we have two equations. This is the first equation and this is our second equation. So we can compare this mechanical translational system with this electrical system, and in this way we have drawn the analogous system of this mechanical system. So we are representing whenever we have to convert or we have to draw or find out the equivalent, or we can say the analogous system for a mechanical translational system, we will just write the equation for it and we will replace these variables F, M, B, K with these variables. You can see that F, it is equal to the voltage. Now here M d2x by dt square. So we are having here d2q by dt square. So we will replace M by L. Here we are having R and B as equal, and here we can replace K with 1 by C. So just by replacing these variables, we will get the electrical counterpart or electrical analogous system for this mechanical system, and in this way we can find out the analogous systems. Now let us consider mechanical rotational system so that we can find out its analogous electrical system. So this is a mechanical rotational system. In this system, T is the torque, theta is the angular displacement, K is the torsional torque, and B is the damping torque. So if we write the equation for this mechanical rotational system, we will get torque equals to so this is the mathematical representation of this mechanical rotational system. Okay. Now if we draw its electrical analogous system, we will have so this is an electrical system having this parallel combination of RLC, and if we write the equation for it, we will get IT equals to IR plus IL plus IC. So putting the values of these currents, we will get IT equals to E by R. Now putting E equals to d phi by dt, where phi is the flux, we will have this equation as IT equals to C d2 phi by dt square plus 1 by R d phi by dt plus 1 by L phi. So we have these two equations. First is this and second is this. So if we compare these two equations, we will get that torque is equals to current. We can replace torque by current, and just this moment of inertia, J is the moment of inertia, so we can replace this by the capacitance. We can replace this damping torque by 1 by R and torsional torque by 1 by L. So in this way we can get the analogous system for this mechanical rotational system. So whenever we encounter or whenever we are having in the question, we have to find out the analogous system of the mechanical rotational system. We will just write the equation for that system and replace these variables with their respective variables so as to get the analogous system for it. So let's summarize this, that what we have to replace in this in the question. The analogous systems, they can be represented by two ways. So there are two ways to find out the analogous system. First is the force voltage analogy, and second is force current analogy. So in the force voltage analogy, what we do, we replace the force with the voltage and we compare the equation for the force with the voltage equation and replace the variables correspondingly. That is, this is the analogy which is used to find out the analogous system for the mechanical translational system. Let's see. How we can represent the translational mechanical system or the rotational mechanical system using the force voltage analogy. So this table is for the force voltage analogy. Just write the first, whatever the equation was, first compare it. This was the mechanical translational system. So here force is equal to the voltage, and if we take it, compare it with the mechanical rotational system, we will get that force, voltage and torque, they are equal. So in the force voltage analogy, we have in the electrical system, we have voltage E, and here we are having the force, which is F, and in the rotational mechanical system we have torque, which is equal to T. Okay, now compare the second variable. It is for the mechanical translational. We have mass. This mass is equal to this inductance L, and for the rotational system it is equal to the moment of inertia J. So here we will write for the electrical system, we have the inductance L, and this is equivalent to mass M, and for the rotational system it is equal or equivalent to inertia J. Now comparing the second variable, we have the damper, or this damper is B, and here we have the resistance R, and here also we are having the damper B. So for electrical system we are having resistance. Resistance is equivalent to damper here, and here also it is equivalent to damper B. Now the last we have 1 by C, that is the reciprocal of capacitance. It will be equivalent to the spring constant K, and here the spring constant again as K. So reciprocal of capacitance that is 1 by C, it is equivalent to spring constant K, and here also spring constant K. Okay. Also we have this charge Q, it is equivalent to the displacement, and here we are having theta, that is the angular displacement. So charge Q, it is equivalent to displacement X, and here we are having angular displacement theta. Current in this force voltage analogy, current I, it will be equal to the velocity V, and here it will be equal to angular velocity omega. So this is how we can find out the analogous system using the force voltage analogy. Force voltage, because here we are having this force and voltage, we are taking them as the equivalent of each other, force and voltage. Now let us study the second analogy to find out the analogous system, force current analogy. Again, we will have the electrical system and translational and rotational mechanical systems. So in this force current analogy, here we will have current, that is I, and in the translational mechanical system we will have force, and for rotational we will have torque. So we are going to compare the force and torque equation with the current equation. Okay, so again consider these translational and rotational systems. Here we are having this as force, and we will compare this with this parallel combination. So we will be having this torque will be equal to current, and this will be equal to the force, Again, we have this moment of inertia, it will be equal to the capacitance, and here it will be equivalent to mass. So for the translational mechanical system, we have mass m, it is equal to capacitance c, and it is here equivalent to inertia j. Now again compare this, we have d theta by dt, here we have d phi by dt. So damper will be equivalent to the reciprocal of resistance, and here also we are having d damper. So both these dampers, they are equivalent to the reciprocal of resistance. So we will be having 1 by r here, we will have here damper B, and here also we will have damper B. Now here we have the reciprocal of inductance. Inductance will be equal to the spring constant, and here also we are having the spring constant. So spring K, it will be equivalent to reciprocal of inductance. Now here we were having flux. Flux will be equivalent to the angular displacement and the displacement. So if we compare these two equations, we will have this spring constant, this flux phi, it will be equivalent to the angular displacement, and here we will have displacement. So we will have here flux linkage, that is phi, okay. So flux linkage is equivalent to displacement and angular displacement. And the last is voltage. So voltage E, it will be equivalent to velocity and angular velocity omega. So in this force current analogy, we have compared this force with the current. That is why it is called force current analogy. And whenever we have to find the analogous systems of this translational mechanical and rotational mechanical system using the force current analogy, we will just write the equations for them and then replace the variables with their respective equivalents. So in this video we have studied the analogous systems, what are the analogous systems, and how we can find out the analogous systems of mechanical translational and mechanical rotational systems using the force current analogy and force voltage analogy. I hope this topic is clear to you. Thank you.